Good morning, one and all. Today I am discussing about the module 2 session module 2 session 3 stresses in soil in applied geotechnical engineering 18 CV 62 under 6th semester civil engineering. So today's our discussion are the stress distribution diagram, contact pressure. So coming to the stress distribution diagram, let us say Q is the load applied on the top of the ground because of the application of load Q. So the pressure will try to transfer pressure. If I am applying a load on Q, suppose this is your ground surface, we are applying a load on Q, the pressure start distributing slowly in the below the ground level like this, and this diagram is called as a pressure distribution diagram. So when it is the load is 0.4 times the Q, you can see here the pressure diagram will be here up to this extent. If it is 0.3 times Q, it will reach us up to here. 0.2 times Q up to reaches here. 0.1 times Q, it is up to reaches here. So this is the maximum pressure at which, because of the application of load Q, the variation of stresses in the ground take place, and this is the depth is called as the significant depth. So coming to isobar, what is meant by isobar? A line joining point of equal elevation. So you will get 0.1 times Q here, 0.1 times Q, 0.1, 0.1, 0.1. If you join all these points, you form a bulb, and this is called as an isobar, and this pressure on this bulb is remains same, and this is called as a pressure bulb. The following example in which the isobar is a bar of intensity 0.1 times Q is plotted. From Bosner's stress distribution theory, sigma z is equal to Q by z square 3 by 2 pi divided by 1 plus r by z whole square whole to the power 5 by 2. Substituting sigma z is equal to 0.1 times Q in the above equation, so you will get 0.1 times Q is equal to Q by z square into 3 by 2 by divided by 1 plus r by z whole square whole to the power 5 by 2. Now, so take out this denominator to the LHS side. 0.1 times Q is equal to 1 plus r by z whole square whole to the power 5 by 2, which is equal to Q by z square into 3 by 2 pi. So if you simplify the 3 by 2 pi, and so if you take the QQ cancels, and if you rearrange this equation in terms of the r by z, then so the r and r value cancels here. If you take out that side, and then if you put r value is equal to 0, suppose if I put r value is equal to 0, then 0.1 times Q into 1 plus 5 by 2, which is equal to 1, that is 0.1 times Q is equal to Q by z square into 3 by 2 pi r. So QQ cancels means the z square is equal to 3 by 2 pi divided by 0.1. If you solve the 3 by 2 pi divided by 0.1, you will get z square is equal to x value. So z is equal to root of that x value. If you do it, that z value is 2.18 meter. So up to a depth of 2.18 meter, the influence of stress on the ground will have a very high influence on the soil stratum. And coming to the isobar, so I can define an isobar as, since the isobar forms a closed figure and it resembles the form of a bulb, therefore it is called as a pressure bulb. So now coming to the principle of superposition. So what is meant by principle of superposition? The principle of superposition may be used to compute the stresses beneath any point. So I want to find the stress acting on this foundation at this point. Now the case is within the loaded area. I want to find out the stress at this point A, B, C, D outside the loaded area. That means we have a 30-40 site. Within the 30-40 site, I want to find the stress at any point within the loaded area, means at point P we want to find out the stress, means this one. Suppose in a 30-40 site, whatever load I am applying, neighboring site, how the pressure influence will be there. That if I want to calculate, then it will be outside loaded area. So your P is your within loaded area, your O is your outside loaded area. Why we have to find this one outside loaded area? Means suppose neighboring site want to make an excavation, the pressure bulb will may be reaching up to this end, and as they excavate it, stresses will unable to transfer onto the lower level, therefore tilting of this structure take place. In order to prevent the tilting of that structure, we should ensure what is the stress at this point. When you are doing excavation, you should ensure that this particular stress on this building ABCD will have a least effect at this point. Likewise, we have to make a retaining wall here or sheet pile wall here, so that the stress should not transfer here. Or you have to design a footing, edge footing in such a that so the load should be within your building, it should not move in the neighbor site. So for that purpose, we need a concept called as principle of superposition. So the principle of superposition may be used to compute the stresses beneath any point inside or outside the uniformly loaded rectangular area. So the two cases, they are case 1 sigma z within the loaded area, case 2 sigma z outside the loaded area. Case 1, when a sigma z is within the loaded area, when the point O, so I am written it as P inside, then the vertical stress at any point P vertically below O. So this O, below O is P at any depth. Z is given by sigma z is equal to Q into I or Q into, so what you have to do is you have to divide this into the 4 parts. So Q into I1 due to this area stress, Q into I2 due to this area stress, Q into I3 due to this area stress, Q into I4 due to this area stress. So therefore sigma z is Q into I, which is equal to Q into I1 plus I2 plus I3 plus I4. So this is called as principle of superposition. Coming to the case 2, when a sigma z is outside the loaded area, when O is outside the loaded area, below O P has to be calculated due to the application of load Q, means. So from O draw a line parallel to AB, from O draw a line parallel to AD. Join O B1 C D1 O. So now the stress at this point you have to calculate it. How to calculate stress at this point? O B1 C D1 is equal to, so O B1 B D2 plus O A1 D D1. 2 times we are added this area, therefore minus O A1 A D2. So now, so once you do this calculation part, so next is sigma z is equal to this area Q1 from this point, Q1 into I1 from this point to this point, minus Q1 into this area I2, and this point Q1 into this area I3, minus Q1 into this area I4. If Q1 is value corresponding to this area, that is radial distance R, therefore I will call it as Q1 dash, this area Q2 dash, this area Q3 dash, this area Q4 dash. So likewise, if you do it, then your sigma z is equal to Q into I, or if you Q1 I1 plus Q2 q1 I1 minus q2 I2 plus q3 I3 minus q4 plus q4 I4 minus into plus, it become minus. So that likewise you have to calculate principle of superposition. Now let us consider a problem. A rectangle of 1.5 meter by 3.5 meter transmits a uniform pressure of 350 kilonewton per meter square to a underlying soil. Determine the vertical stress at a depth of 1.2 meter below the foundation at a point within the loaded area. They given how means within the loaded area 1 meter away from the shorter edge. This is shorter edge and this is longer edge. This is shorter edge and this is longer edge. 1 meter away from the shorter edge to draw a line. 0.5 meter away from the longer edge. This is longer edge. 0.5 meter away from the longer edge, draw a line. The intersection point is your point at which you have to calculate sigma p. So now you have to divide this entire 3.5 meter by 1.5 meter into 4 parts. One is 1 by 0.5, another one is 3.5 minus 1 is 2.5 by 1.5, so this is 0.5. Next one is 2.5 by 1.5 minus 0.5 is 1. Next is 1 by 1. So now the load from this first portion, that is 1 into 0.5 is, load is they given stress kilonewton per meter square, multiplied it by area. Q1 is equal to 1 into 0.5 into 350. Next Q2 is equal to 2.5 by 0.5 into 350. Q3 is equal to 1 into 1 into 350. Q4 is equal to 2.5 into 1 into 350. It will be Q1 dash will be 175 kilonewton, Q2 dash will be 437 kilonewton, Q3 will be 350 kilonewton, Q4 will be 870 kilonewton. Now you have to calculate the radial distance R. R is equal to AC. If I center of this point, so here AC square is equal to AB square plus BC square. That means so 0.5, 1 divided by 2 is 0.5 square, 0.5 divided by 2 is 0.25 square, root of that value is 0.559. Similarly, second one, so 3.5 by 2 square, 0.5 by 2, 0.25 square, root of that one is R2. Third one is 0.75 and 0.5. If you do it 0.75, 0.5, if you do it, you will get this point, centroidal point of this rectangular block. Root of that value is R3. Similarly, R4, 3.5 by 2 square plus, so 1 by 2 square, root of that value will give the R4. So now IB1, IB2, IB3, IB4 are, so 3 by 2 5 divided by 1 plus R by Z whole square whole to the power 5 by 2. So R value is known, depth is Z is constant, so R1 by 1.2 R by Z whole square, R2 1.274 by 1.2 whole square, R3 1.346 divided by 1.2 whole square, R4 0.707 divided by 1.2 whole square. If you do it, I1, I2, I3, I4 value, substituting Q1 is equal to that is sigma Z is equal to Q1 IB1 plus Q2 IB2 plus Q3 IB3 plus Q4 IB4. You will get the total sigma Z, that is 150 kilonewton per meter square. So next, coming to the model MCQ questions. An isobar is a curve or a line or a contour which connects all the points of equal stress below the ground surface, whether the statement is true or false. That is, statement is true. Next one is the principle of superposition. Sigma Z is Q by I. Q into I is IB1 plus IB2 plus IB3 plus IB4. The statement A is true. the principle of superposition sigma z, that is q into I. This is question number 2 is false. Q into I. So IB1 plus IB2 plus I3. This is also false. The fourth one, principle of superposition sigma z is q minus I. This is also false. So next question, principle of superposition sigma z is q by I by q. So this statement is false. Principle of superposition sigma z is I divided by 2q. This statement is false. So if you see the sigma z 0.01q is called as an isobar, statement is true. Option is A. Sigma z 0.001q is also called isobar, statement is false. B. Then sigma z 0.2q is also called isobar, the statement is B. Sigma z 0.1q is also called an isobar, statement is B. So these are all the list of references and textbook. There is a textbooks and reference books I use for preparation of this particular session. I take this opportunity to thank Department of Collegiate and Technical Education officers for giving me an opportunity to deliver the lecture. So thank you for attending the class, students. If you have any doubt, please feel free to ask. I request all the students to go to the LMS portal for the study material, PPT material and videos and MCQ. Solve more MCQ questions. If you have doubt, you can feel free to ask. Thank you.